So writing two-step equations. In chapter 1, you did learn about writing verbal sentences as one-step equations, and some verbal sentences can translate to two-step equations. For example, the sum of 400 and 15 times the number is 700. So you can let n represent the number we don't know, just like in chapter 5, we were learning about percents of and what is and of things, and then fill that in. The sum tells us we're adding 15 times a certain number plus 400 is 700. So is still represents equals. All right, so some words that mean, just a recap, and I'm not going to get all of these. You want to brainstorm some too. So maybe even pause here and try to think of some words that you could read that would come up and you'd know you need to add, subtract, multiply, or divide. You can fill this in as you see fit too. It doesn't have to be everything that I say. I won't get to all of them. You may have some other ideas that you can share in class as well. So for adding, like we just said, sum could be one of the words. Saying all together could be something. Add-end could be something. Let's see what else. Just the word plus. Saying the words more than. Anything else you want to fill in is good too, and bring some thoughts to share, or as things come up that you read, maybe you'll recognize some key phrases as well. Subtract. Big one. The answer to a subtraction problem is called the difference. You may just hear the word minus. Less than. What else? Different things that you can think of. Go ahead and write those in. Just giving you a couple. I want you to come up with some too. Process of thinking. Multiply. Different words for multiply that might come up would be the product. Another one might be just saying to multiply. Oopsie. Might just be to say to multiply. Times is always a good one. And again, brainstorm some more. These obviously aren't the only three things. You can come up with some as well, though. Divide. Answer to a division problem is called a quotient. So the quotient of, maybe if you said share equally, maybe groups of, or by groups of, split into, because groups of is something for multiplication as well. So think about some of those. Those aren't the only ones again. Definitely some things to think about. You can always Google some different things, both, in, all, left, less, take away for subtraction, share equally, each, every, different things like that. Okay, moving on then. So getting to the bulk of this, translating sentences into equations. So you can translate sentences into equations by reading a sentence. Like here, 8 less than 3 times the number is 23. So things that stand out for me are the words 8 less than 3 times a number is 23. If I just write this out, we might think this is 8 less minus 3 times the number is. But the difference is you have to know that subtraction cannot be done, is not reversible left to right. So this is 8 less than what 3 times the number is. So you have to recognize that this is going to be 3 times a number, and 8 less than that total is represents equals, and then that negative 23 still applies. So you may see here 3n, and they use n instead of x. As long as it's a variable that we still don't know at the time, that's okay. So they've used x. I tend to use x instead of n. The book tends to use n. Either one is fine. This means the same thing. It means the unknown variable multiplied by 3, subtracted 8, ends up to be negative 23. Another one with keywords, 13 is 7 more than twice the number. So at first thought, I'm going to say, okay, that's 13 is, just writing down what you're reading exactly, 7 more than twice a number. And that's what they came up with too, but they did this correctly and they wrote that variable with the coefficient first. Okay, so that's how you would want to write it. Instead of 7, it can look like this. That's good too. Lastly, the quotient of a number and 4 decreased by 1 is equal to 5. Notice that the comments tell you the order in which to do things. So in this case, it's the quotient, which tells me I'm going to be dividing at some point, of a number, unknown, and 4. So I'm probably dividing that number and 4, because it's the quotient of those two things. Decreased by is a good thing for subtraction. You can put that on your chart. Is equal to 5. So if I were to predict, I might say that this is going to be equal to a number divided by 4, the quotient of that, and then subtracting 1 from that ends up to be 5. And there you have it. So you do have to remember that they put those commas there because they had to tell you that the division does come first in order of operations. After you divide, then you'd end up subtracting. To solve, of course, you do the inverse first. So checking these, go ahead and check, maybe pause me here and then try to check these ones out, and I'll uncover the boxes when you come back. So 15 equals, let's try this one, 15, so I'm obviously going to say that's the number 15, equals 3 more than 6 times a number. So if I were to write that out correctly, I think it would be 15 is 6 times a number plus 3 more. Sure enough. Second one, if 10 is decreased by, so if 10 is decreased by, meaning I'm subtracting from 10, so 10 minus the quotient, so I see quotient, division of a number and 6, the result, meaning is equal, 5. This is a little tricky because you have to see that 10 is being decreased, so you're subtracting from 10. So you're not subtracting 10 from this, 10 is being decreased by. So it's going to be 10 increased, I'm sorry, I totally read that wrong, increased, not subtracted, increased, it's been a long day, increased by, you're going to be adding whatever the quotient is to 10 to get to 5, increased. Important to read, and that's why, checking my solution, what I said didn't make sense, showing you and modeling that, checking your answer and finding your mistakes and learning from those is really important in this math life here. So the difference between 12 and a number is 18. So again, I see difference. So I know that difference means subtraction. I do know that this time. The difference between 12 and twice a number. So we're taking the difference between 12 and 2 times a number. That is 18. So equals. So subtracting twice a number from 12 to get to 18. Hopefully that's some good practice for you there. And last little page, word problems. This is where you'll see it the most. So a personal trainer buys a weight bench for $500 and W for weights for $25 each. So the total cost of the purchase is $800.50. How many weights were purchased? Some keywords that I do see right away are is. We know that's our total. So something's going to add. So how did we get to our total? Well, we got to our total by the person buying something for $500 plus is a good indication of end. A certain number of weights we don't know at $25 each. So to put that in perspective, this is really the bench plus $25 per weight got us to our total of $850. So we can let W represent our weights, and we plug in those values. $500 plus $25 per weight ended up at $850. Notice our directions did tell us to solve the equation this time, so we're going to do that. And we're going to start, after we wrote our equation, we're going to write it again. So we really have 500 for the bench plus 25 per weight is equal to 850 total. So we find out how much did we spend per weight. That's what we're wondering. How many weights, not how much did we spend. The question is how much, whoops. Question is how many weights at $25 a piece were purchased. So we do our equality subtraction, and we subtract 500 from both sides. And we end up with 25W is equal to $350. So right now it looks like without the bench, the trainer would have spent $350 just on weights. So then what you choose to do, and I like to talk through and think about what am I doing each step. So that's what this step means. $350 on $25 weights. So divide by 25. So how many times does $25 fit into 350? And you end up with the weights of 14. So what this means is, in a sentence, is that the trainer bought 14 weights at $25 a piece. That's what that ends up meaning. Very good. So that ends up meaning that, and we'll go on to our next problem. You and your friends' lunch cost $19. Your lunch costs $3 more than your friend's. How much was your friend's lunch? So this one, we know that the total cost together of my friend is 18. So my lunch, say maybe my lunch, or your friend's lunch, you plus your friend, say. They both don't equal X because we know that your lunch costs 3 more than your friend's. So if your friends represent X, yours is 3 more than that. We can show you this in a plot here. So your friend's lunch is what we're looking for, X or F for a friend. But we do know your lunch was their lunch plus $3. You must have got a side of fries or something. If you're Miss Simmers, that's what you would have done. So this is what we find. I hope that makes sense to you, is that you have to decide, what is the question asking? What am I looking for? Pick a variable based on that. So friend's lunch, so the book picked F. We don't know what our lunch alone cost, but we do know it was $3 more. So it's $3 more than the friend. So that friend's variable still counts. So this problem considers a little bit more of combining like terms. So to solve, we're going to write your friend's lunch plus your lunch, which is $3 more than your friend's, added up to a total of 19. So how much was your friend's lunch? Well, notice we have to combine like terms here. We have 1F plus 1F, which is equal to 2F plus 3, which is equal to 19. Combining like terms before we can solve. So then we do our subtraction to both sides, inverse operation. And we get twice your friend's lunch. So pretty much this is your lunch and your friend's lunch without the $3 fries you ordered, is equal to 16. And so to divide that by 2, to find out just your friend's lunch alone, 2 divided by 2 is 1. So I have 1F is equal to 8. So what that means then, situationally, is that your friend's lunch was $8. You could also infer that your lunch was $8 plus $3 for a total of $11. And that would make sense because 11 and 8 add up to your total of 19. So last one to give a try. It says a measurement. The perimeter of a rectangle is 40 inches. The width is 8 inches shorter than the length. Write and solve an equation. So you can pause, try it. I'll uncover the box after a little bit. So we do know perimeter is telling us to add the side lengths together of a rectangle, and that the perimeter is 40. So what I know is that I know that perimeter is twice the length plus twice the width of a rectangle. It looks like I also already know the width is 8 inches shorter than the length. So I don't know the width necessarily, but I do know that the width is 8 inches shorter than, which means subtraction, than the length. So the length minus 8. So what I can do is plug in what I know. What I do know is the perimeter is 40. And I also know twice the length plus twice the width, which I happen to know is the length minus 8. If you can't tell that's an L, maybe make it a capital L instead. And now I have an equation that I can go ahead and solve. So I'm going to solve this equation by doing distribution first. So I do 2 times L and 2 times negative 8. So I'm going to rewrite this as 40 is equal to twice the length plus twice the length minus 16. So I combine my like terms. Oopsie, that got a little aggressive. 40, I'm going to rewrite this right down here. Excuse me. 40 is equal to 4 times the length then, 2L plus 2L minus 16. So I combine like terms and distributed, so now I'm ready to solve. I add 16 to both sides. And I get 56 is equal to 4 times the length. So I divide by 4. And I end up with 14 is the amount of my length. So if I know my length, now I still need to know my width. So I would plug my length back in, and my width is my length minus 8. So that would mean my width is 6. And this is in inches. So hopefully I did that right. Let's see what the answer says. Sure enough, I have the same equation. Maybe flipped around. I put my 40 in front. They put it at the end. That's okay. Length is 14 inches, width is 6 inches. So it does take a couple steps. It does take some showing your work. Hopefully, since you're using a regular pen or pencil, yours is a little neater than mine. Write down some things you know, some things you're wondering. Rewatch my video, someone else's, examples in the book, personal tutor, Khan Academy, whatever you need.